Let's do a couple more examples where the rates are percentages. Example 12 says, including an 11.5% lodging tax, the cost for a one-night stay at a bed and breakfast, including tax, was $198.47. So first thing I'm going to do is write out the form of a linear equation that we're seeing most often, which is start plus rate times x equals an ending value. And here the rate is going to be this percentage. So I'm going to write rate is 11.5%, and then convert that percent to a decimal, in this case 0.115. And then we have to figure out what this $198.47 is, because it's either the starting value or the ending value. So for now, I'm just going to put cost including tax. So cost including tax equals $198.47. So it says write a linear equation modeling the scenario. So we're going to use this kind of model. And then it says the cost before tax is the unknown. So they're giving us a big hint there, which is x is the cost before tax. In other words, that's our starting value. So it's very similar to the last one, where instead of start, I'm going to put an x. Instead of rate, we're going to put the percentage written as a decimal. But then we have this second x. So it's a little different because there's two different x's there. And then the end amount is what we're given, $198.47. All right, well, let's combine like terms. This x is really just a 1x, and we're adding it to 0.115 x's. So together, this makes 1.115 x's. And that will equal the $198.47. This is actually sort of a shortcut way to add a percentage to a value, is to add 1 to the percentage. But in our case, we're trying to solve for x. So I'm going to divide both sides by 1.115, divide by 1.115, and then use a calculator to get this number, which in this case is $178. And then, of course, we should write a sentence. And luckily, we wrote out lots of information about like what we were trying to find. So the cost before tax is $178. The cost before tax is $178. Great. Let's try one more. Example 13 says a washing machine is marked down to $603 after a 33% discount. This problem is going to be a little different in that they're talking about discount. And what that does is it makes the rate negative. Much like an example we did a couple videos ago where someone was losing weight, that made the rate negative as well. So a discount does the same kind of thing. But it is still that the rate is the percentage. So, but let's write it as a negative. Maybe that'll help us remember to just put it over here too. So our rate is going to be negative 0.33. The marked down price is $603, so let's put that. Marked down to $603. And then it says write a linear equation modeling the situation where the price before the discount is the unknown. So I'm going to let x equal the price before the discount. And in other words, that's our starting value. It always helps to keep in mind this model that we're using, which is that the starting value plus a rate times x equals the ending value. So with that model in mind, the starting value is what we're looking for. So instead of start, I'm going to put an x. And then we still have this plus. That plus sign looked a little weird. The rate, but we have a negative rate because the price is being discounted. So for the rate, I'm going to put negative 0.33 times x. And then the ending amount is what we ended up paying in this case, which is $603. All right, so hopefully that setup makes sense. Another thing that we often would want to do is think in terms of there being a coefficient of 1 in front of that x. And because the second coefficient is negative, we need to subtract those values. So it's 1 minus 0.33. So what we end up getting on the left side of this equation is 0.67x. So there's, this is another one where we might want to think about, well, what is that 0.67 really talking about? And after a 33% discount, you end up paying for 67%. You end up paying for what's left after the discount. And that's really all this is saying, is that 67% is what of the original price is what I'm paying for. To find that original price, we're going to divide both sides by 0.67 or 67 hundredths. And once I put that on a calculator, I get $900 if you do 603 divided by 67 hundredths. And that's always confidence building when we get a nice round number like that. So what we just found is the price before the discount. So I'm going to write that the washing machine cost $900 before the discount. So hopefully that makes sense for how to deal with real-life applications that involve linear equations.